Artificial neural network models are the foundation of deep learning, which is a subdomain of machine learning that has demonstrated huge potentials in recent years. In this tutorial, we will look at how artificial neural network models are defined and trained, as well as how they are related to linear models. Artificial neural network is a type of machine learning model that represents the mathematical relationship between inputs and outputs as a connected network of simulated neurons. The output of each neuron often depends on a nonlinear activation function of its input neurons. The connections are defined such that the output of some neurons can be the input of other neurons. Here is a toy example of an artificial neural network model. It consists of 3 layers of neurons that are connected by weighted edges. The input neurons receive information from the observed data about the input variables and pass along that information to the hidden neurons. Each hidden neuron receives a weighted sum of its inputs and gets activated according to the activation function h. The results of hidden layer activation are passed along further to the output layer. Each output neuron receives a weighted sum of the hidden units that form its input. It then produces the final output according to the activation function f. Artificial neural network models are trained using the error backpropagation algorithm. The first step is to compute the activation potential of each neuron using the feed-forward process that we just described. We can then backpropagate the errors starting from the output layer. For each output neuron, the error is simply the difference between the model output and the target value of the variable. These errors are distributed back to the hidden neurons based on the weights. For each hidden neuron, the error depends on a weighted sum of the backpropagated errors from the output neurons, as well as the first-order derivative of the activation function h. These error terms are used to make updates to the parameter estimates for the weights. Although artificial neural network models may seem complex at first sight, they're actually quite closely related to linear models. Here is the simple linear model where the error term is omitted. Here is a linear basis function model where the input variables are transformed using fixed basis functions. Here is the artificial neural network model where the basis functions depend on parameters that can be trained using the backpropagation algorithm. This wraps our introduction to neural network. Thank you for watching. See you next time.